So we're gonna start now. We are now on hands-on or tutorial on manipulating the images. So we're gonna use this file, okay? And this file basically, you're gonna use can be found in your eLearn. So eLearn, you have this one. Just click this one, and you can have this. Okay. So at the moment, I'm just using PDF, so you can copy paste the code, rather than using the GitHub. I think GitHub is a bit more complicated for the new beginner. So the best thing is just to use the PDF here. I upload the PDF, so you can just copy paste into the editor of Python later on. So we are here, okay? So this file you can find e-learning, okay? Download from there, okay? Just get ready, download there, just get ready on your screen. So later on it's easy to copy paste. All right, now let's start with the first step we're going to do is just open your Google and you just type Google Colab, okay? And just click this one, okay? Okay, you're gonna have, you can, if you please cancel, it's okay. So this is the editor, what we call Google Collaborator. Google has produced this for all of us. They produce this for free. So just connect. But before you connect, you need to has an account there. So your account is there. Okay. So this is me. Putra is me. So I have signed in as my Google account. So you need to have a Google account in order to use the Google Colab. Just like you need to have a Google account to use the Google and so on. So you just please connect here. So we will connecting to the cloud base somewhere there, and just wait for a while. All right. So someone I use Jupyter. It's okay, Jupyter. Okay. Has a Jupyter there. If you don't connect to the Google Collaboratory, you can download Anaconda, as what I tell you on the WhatsApp. Please refer to the WhatsApp and follow the instruction. Once you install the Anaconda when you successfully install Anaconda on your laptop, you're gonna have like this. So you're gonna have like this on your window. Okay, you're gonna have Anaconda 364-bit. If you click here, you can see there. You can click Jupyter Notebook or Anaconda Navigator. I think you can click Jupyter Notebook here. Straight away, you're gonna show to the Anaconda. Okay, but you can download it later. It's good to have a Jupyter Notebook. Okay, there is a weaknesses using the Google Colab, which we will talk about it later. But it is recommended you have a Jupyter Notebook because everything is in your PC, laptop. Everything you do, you save everything. Okay. Once you use Google, everything in Google Drive, then it's not permanently there. All right, get back to here. Now we're going back to this one. Okay. So this is mean you have connected. If you click this one, it's already connected to the local runtime. This is hosted runtime. Okay. Probably sooner you're gonna have connect to the quantum computer or GPU. Last time we have a GPU here, but this is this means that you are connected. And what you need to do now is just go. This is one of the file. Okay, but you can go here and create a new notebook. Okay, keep looking at this because we want to connect it to the Google. Okay, so when you connect it, mean it is now is ready. So what you see now is a new file you want to create. Okay, here is a topic. You can change to intro to Python and Jupyter and Colab or Jupyter. Okay, and press return. So now your file is named intro to Python and Colab. Okay, so basically this is where you write your thing. Okay, let's say this one. I have a lesson here for a Python. Hello world. If you put this one, just this is intro for a while, and you just copy paste here, Control V, and then what you do is just place this one, and then it really gonna be there, hello world, and then it means the green button here mean success. Okay, so this is the editor. Once you have this, you can have code. Press this one for the new one. Okay, for the new one. So new one, you can type anything Python if you like. In this case, I put it like this, and okay, and then just press this one. This means you run. Okay, now kita input 1, 2, 3, 4, 5, 6. I'm going to input the number, press return, and you're going to have the output there. So this is a Python. What you're using is a Python. Python a bit more simple thing, print just like this. But those who are familiar with Java, good, it is also good. No worry. Almost the same. But Python is a bit more simple. Okay. Now you got here as well text. You can have a text. You can write down something here. Okay. And then this one, I think you can go up. Okay. You can go up until there. Okay. And this is a text. Okay. If you put, you can do on your own later on. There is so many instruction in the Google, on the Google. You can download and look at the YouTube as well. All right. So this is basically Google Colab, easy for us. And what you see here is you got file here. Okay, new notebook, open notebook, upload, rename, copy in Drive, copy as GitHub, and so on. Okay, and you got edit here. Select all cells, select, copy, paste, find. So you can go around with this one. And you got runtime. So run all, restart runtime, restart and run all. Okay, let's go restart and run all. They're gonna restart from the beginning. Okay, this first, then this second. 1, 2, 3, 4, 5, 6. Return, and that's it. Okay, so you can play around, and then you got tool. Okay, keyboard shortcut, for example. So these are the shortcuts. Add a command, control alternate M. Add a command basically is get play around with. This is the command. Okay, and so on. Add code cell. You can set yourself here. What is the shortcut you want to use, and other things. Okay, and what else? All changes are saved. This is already saved. It's saved on the drive. Okay, he put in the drive. Automatically, he put on the drive. I think. Yeah, you can check it later. Okay. I think when you save here, they copy in the drive. You can save in the drive. You can save. Save here mean by default on the drive. You can saving and so on. So this basically on the left corner on the top. Okay, this is table of content of this one. You can see get play around with Google Colab with Python. Get play Python. Okay, so you can go here, then you will go here, and if you press this one, there's a new section here. Okay. Okay, so this is a right. All right, so this is for searching. This is for formula. This is for, if you click this one, you're gonna have a directory. So in this case directory, you have readme. This is one of the project, California Housing Test. This is not the image. This is just a numerical number, reading data of housing train and test. Okay. All right. So these are the directory, and this you want to mount to your drive. At the moment, your drive is not mounted in this here. So if you want to access data from the drive, you can click here. So your data will be connected to your drive, right? All right. What else? This is insert cell, code cell, take cell. So this one is basically this one, the same thing. You can put more. Okay. Put it down. Okay. Just go to here, probably like this, and okay, we paste, and you just can easily go here, and okay. So this green mean it is a command. It doesn't execute it. Okay. So you can press play here. So you can see ABC and ABC 5 to A, 3.2 to C, hello to C, 3.2 to B, print ABC, you can come out there. All right, now what I'm going to do is I'm gonna choose my file. Okay, in your case, you stick to the new notebook. I'm gonna open my my Google Drive. Okay, so I got a lot in my Google Drive. Okay, so this is the code that we have just now, automatically stored in Google in Google Drive. Intro to Python and Colaboratory. Okay, we just do it just now, and what we're gonna do is this one. Okay, just let's look on the tutorial image 3. Okay, so this one. Okay, so I'm gonna open this one. In your case, you can proceed with new notebook. Okay, new notebook. And when you open the notebook, go to here, go to this one. Just copy paste. Okay, just copy paste. I think copy paste this one first, easy. Leave it the comment here. This is what I print from my collab. Okay. Now this one. Okay. So this is some of the library used in Python when we are dealing with deep learning. Okay. Okay. Deep learning is a subset of machine learning. The advantage of deep learning is you don't have to do the feature extraction. You know, it's just simply we don't do it. Let the deep learning do it. Okay, so here deep learning we need normally we need what we library call matplot library. Okay, so this matplot library is a library that can plot anything, graph, bar chart, anything, any plot graph. You also can plot your images, not in terms of PNG or JPEG, but you're gonna plot in an array using the plotting. You got x-axis, y-axis, and all the matplot library we refer as PLT. So if we want to use a matplot library, don't forget to put PLT in front of the code. So matplot library has one library, sub-library called images. We're gonna use this library, matplotlib.image as mping. And we also use OpenCV too. Okay, and you can go on, you can go on import anything. So you also can import TensorFlow. So this is later on. Okay, TF. Okay, all right. So we're gonna have TensorFlow later on. We are working on this later on. Okay, TensorFlow later on. I think week number 3 or something like that. Okay, just run and have a look. Always look at this. Connecting mean okay. Well, so green means okay, no problem, everything will be okay. Now we are using matplotlib displaying image. So first you're gonna upload your photo from your PC to the directory temp on the left. Click the directory temp and click uploaded. So this one basically means you're gonna have go to this here because we're gonna use image from my directory. So the image must be put on this Google Colab first. So this is the going back a bit. Going back. So going back, you're gonna have temp here. Okay, temp. Because I'm using temp here, directory. Okay, so I'm going to read the image from directory called temp, tmp. The tmp contain my picture of Dean List 1 JPEG, .jpeg. So I think the image is around here. If you click here, you don't have Dean List. Okay, you don't have Dean List. So you couldn't read. All right. If you click this one, error because you couldn't find this one. So what you need to do is this one, upload and go somewhere else. Where is the picture? I think in the picture and find the Dean List. I think, okay, this one. Okay. Open. Okay. So we're going to look here, there. You got the Dean List there already. Okay. On the temp, direct temp. So now you can rerun it back again in this one. All right. Now you have Now you see here what you can see of this image. When you run this matplotlib Python, when you read using this one, they're gonna change your photo into array. So here what you're gonna have is you got column about 1,000 something, and you got row about 700 something. So this is the resolution is 700 times 1,100 something. 710 times 1,100. Okay, so this is the column and row of your image. And when you look at this, what do you think? It is a grayscale. It is a color.
It's a color.
Yes, color. Do you know how many bits depth of this image?
I guess would be 8 bits.
You guess will be 8-bit.
Yep.
Yes. Okay. Others? Remember just now we talk about
24.
Okay. About this one. The bit. This is the color depth. We got 8 bits. We got 8-bit, 24, 4, 6, and so on. So this, what do you think? Okay, never mind. Let's check. So what you're gonna have here is we're gonna check the image detail. We're gonna have an image shape. So IMG is this one, IMG, and it is using a matplot library. And IMG has understand the image as a array. We got the x-axis and y-axis, and this is the column, and this is the row, and then this is the column. So we can know each pixel. So how many pixels are there? 1,000 something times 700 something. You got pixel. So you want to know how many bits here? 24 bit, 4 bit, 3 bits, 8 bits. So we're gonna run this. So you see there, it is 3. 3 mean what?
3 channels.
Yes, 3 channel. What it is? RGB. Yes, thank you, RGB. So this is 712. 712 here is maximum, the row. And the column is 1,272. All right, this is the size. 712 times 1,072, you get total number of pixels. Then you time 3 or 24, 3 channel, 3. Okay, you can have like this. I think it's 24. 3 mean 24. You can have bits. So the size, this is in bit. So the size will be 2 million bits. Okay, this is a raw image. Okay, 2 million bits divided by 1,000, you can get kilobyte. Then divided by another 1,000, you get megabyte. All right, that's the image. Okay, and you can print again. So these are basically, this is a NumPy. Okay, now matplot library use NumPy array. So the array is a NumPy. When you got NumPy, mean you have a location of pixel, you can subtract, access the index, anything. You can work. You can operate these images. Okay. So if you print the images again, remember the word print. You go type image. If you print just like this, EMG, you're gonna have like this. So this is big, you know. So this gonna be the content of the first pixel. This is R, this is G, this is B. So this is 3 channel. So this is the first pixel at the location, I guess, at the location of 0, 0 there, I guess, okay? Because this is the first, the end will be 1000 something here, okay? So the first pixel here basically contain this one, okay? 5. So what is 35, 17, 15? What color is that? So you can refer to this one, okay? What color is that? You can have to look at the lookup table actually. This is a dummy. This is an example, not exactly like this. There has a color lookup table there. All right, so and move on. So this is green, okay, already done. Now we move a little bit. Now we try to look what number in the pixel location of 100 by 100. Okay, so we can have pixel image location 100 by 100 mean that so this is the image. So this is the image. Okay, location 100 by 100. So we're gonna have somewhere here and this one, this pixel. What is the value of color on this pixel? So you can have like this. And so over here, the pixel value is 42, 18, and 14. Okay. Right. And if you look at the next to it, what are the pixel value? Just in case, okay? I just want to look. 44, 8, 19, 15. You see the difference, right? So if you want to crop the picture, make sure number is not to change. If 18 here become 100 here, if you change to, because you see 18 to 19, 14 to 45, so the gradually is smooth, like a real photo. Okay, if you crop, make sure this number is smooth, so it doesn't look like cropping. Okay, copy paste. All right, so this is the image. So location 100 by 100, 100 here, and here is 42, 18, 14. And next to it, 101 is 44, 19, 15. So not much different, but a different value. Okay, channel. All right, just move on. So this is the other way you want to look at the RGB. Okay, at location 100 and 100. Okay. 100 and at location 100 and 100 there, the RGB is 42, 18, and 14. Being the same like this, okay, the same thing. So that's you want to see the RGB value. Now we want to change the pixel value. Just now, okay. Just now, okay, so the value of this one 100 is 42, 18. We're gonna change the value basically. So we're gonna change the value 42 into 255, 18 into 255, 14 to 255. We're gonna change this value, so you can run this. So you got error. Let's see what the error is talk about. So assignment destination is read only. So you cannot override it. So you can go here, search. If you do not understand what this is all about, you can just click here. I'm gonna pass you to the. Okay. All right. All right. You're gonna pass you the info. So in this case, the image is read only. I'm gonna change it into writable. What you're gonna do is I'm gonna import NumPy because I'm familiar with NumPy. Then I need to see the flag of the image, and I see that the writable is false. So I'm gonna make it is true, so can be readable. So I don't work on AMG, I work on A2. So let's make a copy of AMG to A2. And okay, then I'm gonna change the writable here into true. So I can make amendment, I can modify. Okay, so then let's see the flag again. And so writable is true now. You can override the pixel. Now let's change the pixel 100 to 255. Okay, now the pixel is 255. Okay, so if you look back in detail, okay, so location at 100 now is okay. So this is IMG. So let's see the A2. So since we have A2 there, A2, isn't it? We're not working on AMG. We will call it A2 and AMG is the same image. So you're gonna have 255 now. So the value is changed now. Okay. Since it is only one pixel, you change the value, our eyes didn't recognize. Let's say we please implode. Okay. So we're gonna see the picture after we change the value of 255. Mana tadi? Okay, this one. All right. Now the RGB of A2 is 255. Okay. So if you put more code there and you're gonna show the image, but now it's not AMG A2. Okay. And you run it. So it is basically 100. It is a new number 2555, but it doesn't recognize here because it just pixel is too small. Our eyes couldn't recognize it. Okay. All right. Now we move to another one is to get block of pixel and move somewhere else. So we're gonna have what we're gonna do here. We're gonna have this block of 300 and 400, 300 and 400. I think this one, this block. So this basically meaning the block here. 300 and 400. Okay, up to 300 and 400. Okay, I think it's this one. Okay, this one. Okay, this block. We're gonna move this block. So first, we're gonna let the block into one name, then put the new to the new place here. There. This put here, then this new place with rectangle. See, this is a new place we want to put. 100 and 200. 100 and 200 somewhere around here. Okay. And 100 and 200 somewhere around here. So we run this. Okay. We just assign block. Then we display A2. Okay. So if we display A2, you can see this here has been moving to here. Okay. All right. So this is where Photoshop do it like this. Even the pen. You know the pen? Pen here, pen. There. Okay. So this one basically use this one. Okay. Easily can use this code for making a pin. You can drag on there when you're cropping. Okay. When you're cropping, you just get this block and then you move somewhere else. But the thing is remain the same. And you can change the block here into all white or blue or green or whatever you suit. Okay. All right, let's move next. Now what we're gonna do now. So here is 4240, 40, 4240, 40, which 40, yeah? This one, 40, 4240, 4240, 4240 up here. 700 and 100, so this block, okay? This. So this means this block. And we're gonna put into here, okay? So this block is here. We're going to move this to here. So we're going to run this. Ada hijau lagi sebelah green. Green mean okay. And it's now, then we're going to plot the figure. Then you have moving my head to there. Okay. So that basically, when you understand the pixel value, the architecture of the image, color depth and so on, then easy for you to manipulate with NumPy or whatever. Now we're going to move to change the image into grayscale, or the grayscale into color, or color into grayscale. Okay, let's look again on the original image. Okay, now we're going to use Pillow here. Pillow is another library. Okay. I think Matplotlib only support PNG, but my image is JPEG, so I'm gonna, I think it is only PNG, but anyway I just put Pillow here just to show you there's another library, Pillow. Import from Pillow, import image and import NumPy. I'm going to using NumPy as well as MP. Okay, and look, and we're gonna use it later. So let's plot the original. So this is the original. Okay, the original picture. We're gonna change this into grayscale. So remember, what how many bit here? What color depth here? How many channel? 3, yeah. This one 3 channel, yeah, RGB. Remember, 24 bits. Okay. Let's print the original. Okay, it is a 3 channel RGB, and the column you get 1072, and row is 112. So this is the size in bit. So I want to change to grayscale. Grayscale is 1 bit. Okay, one channel, not 3 channel. Grayscale mean no color. So what we're gonna do is, I'm using another name in gray, image grayscale, using the NumPy array, and image open from the same list. The deal list JPEG is this one, and I'm gonna convert into grayscale. So this is the code for converting into grayscale. Right? Just simply like that. And then I'm gonna, after I doing this, I'm gonna see the shape. Okay. Are there still 3 channel? Just hold on. Why it doesn't happen? Why is array? What is image is not defined? Mean what? Anyone? Simply because you don't run this. They doesn't know the image is. We are using Pillow, but we don't run this. Let run this. Okay. Because we are using Pillow library here, but you didn't run it Pillow yet again. So we are using a Pillow library there. So okay, we use NumPy array as well. So we're gonna run it again. So now, now the row still the same, 712. The column still the same. Now no more 3 channel. When you don't have 3 channel, you just put like this. It mean 1 channel. This mean 1 channel. Okay. We only work on 1 channel or 3. No 2, no 4, no 6. Okay. Remember that we only go 1 and 3. When like this mean 1 channel, grayscale, or 1 color. If you have like this 3, mean it is RGB, 24-bit color. All right, and so let plot it in gray. So this is a grayscale basically. Okay, this is considered grayscale because you want to change color. You can use other thing to make more better to grayscale. Okay, I think the convert L doesn't change it totally to grayscale, but somewhere is there. Okay, you want to change grayscale. Now I'm to resizing the image. Okay, now the original image are still using the same original image. Okay, and this is the original image. Okay, if you print the size, it's still the same. It's 3 channel, 712 and 1072 column. Okay, resolution. And we want to recycle it to 28 to 28. So mean that we want to change it 28 by 28 3 channel. Okay, that's what I intend to do. You follow? Hello?
Yep.
Yes or no?
Yep.
Yep. Okay, thank you. So I'm gonna change. I'm gonna remain the 3 channel. I'm gonna change this too big. Okay, 712 and 1000. I want to change 28 to 28 because normally in deep learning you need small thing. You cannot have a big thing. Big and small, the picture is still the same. We can understand. You know what I mean? If you have a color dog and grayscale dog, people can still recognize it is a dog. So color doesn't important there. The size doesn't important there. You make it small. So when you make it small, it means like this. Okay, you can run this. I'm still using array, and I'm gonna resize it. This is the code. Resize is 28 to 28. All right, I'm gonna resize it. Just let's see what the picture is all about when you're resizing it. There, all right. For the deep learning, this is more than enough. This picture more than enough. These pictures are good for deep learning, but it's too acute, too consume space because it's 712 times 212, and it is a 3 channel. How many size are there? 2 million bit, too big. Whereas if you change to this 28 by 28, the size become 2000 bit. 2000 bit mean 2 kilobit. Very small, but deep learning can still recognize this because it just learn the pixel here. It just learn the characteristic, not exactly. Okay, so this is where you got. If you see this, so it is still 3 channel, remain the same like the above, and now it become 28 by 28. Okay. All right, and then move down. I'm sorry, I didn't read the chat. Okay, there's many chat to. I'll go through the chat later on. Yes, import. Okay, good. Some of you follow. Okay, never mind. I'll talk about the chat later on. All right, now let's resize 2 by 2. Made even small. 2 by 2 and 3 channel. Okay, still use the same, but resize into 2 by 2 from the original. Okay, so DINList JPEG is this one. Okay, we're gonna change into 2 by 2 from 2012 712 to 1072. We're gonna change to 2 by 2. So it's still the same. You're gonna running it. Grid mean okay. Then we're gonna print the size. Now it is become 2 by 2 and still 3 channel. Okay, and it is 12 bit. 12 bit is too small. You know, 2 by 2 is too small. And if you plot the picture, this is impossible to be processed by deep learning. What does it mean? Doesn't mean anything because it's just a box with 4 different color. This is 4 color out of 24. This is the 4 color out of 2 the power of 24 type of color. Okay, we got a 2 the power of 24 type of color, but this is 4 only out of them. So if you print IM, what is IM? IM is this one. Okay, IM this one. This is image. Okay, the image M is 2 by 2. Print im, print im. Okay, im. Okay, we print im. Okay, let's see what the thing. Now it becomes smaller. So if you see, what is the content of the pixel here? Anyone? I didn't read the chat. Can you say? Can you just say something on the? So what's the value pixel here?
Very small. Less than 1.
Huh? So the pixel value here basically is 115 R. G here is 105 and blue is 103. Remember 3 channel? This is 3 channel. This is 3 channel. Okay. So this is 3 channel. 3 channel mean 24-bit RGB. And it is 2 by 2. 2 by 2. This is 2 by 2. Two row, 2 column. And this is 3 channel. So this, when you print this, you're going to have this there. So R here is 115, G here is 105, and blue here is 103. 3 channel for this one. And this one, what's the value of the pixel here? RGB?
152, 144, 143.
Yes. Here also the same. 70, 58, 56. Here 79, 66, and 67. So the combination of RGB found this color. And this is a 3 channel. Okay, this is a 3 channel. I mean it is a true color. Okay, it is a true color. But somehow it is too small. It doesn't seem. It is a color basically. All right. And so this is working with the Google Drive basically. So okay, everything so far. So this is basically working with Google Drive. Okay, on Google Drive. So from Google Colab import drive. So just let's run on this. Okay. So I want to try to connect to the Google Drive. Okay. What is this? Okay. So he tried to connect to a working area. So let me see what's happening down there. Okay, just put allow. Okay. All right. Now I connect to my Google Drive. Okay. Before this, I didn't connect to the Google Drive. Okay. So basically mounted. This is the way, but you can click here, I think. Okay, mounted. So this is the original image, what we have. And let's store image in Google Drive. So this is this is right. All right. So true mean they have draw this into the ImGray. Okay, what file did I use? ImGray. ImGray is a grayscale. Okay, we have to convert to into grayscale just now. So it is on the content drive, my drive, Colab, notebooks, ImGray. Okay, so if you go to your, where is the, no, okay. So you can go to the thing, refresh. Okay, just go to the Google Drive. My drive, okay. All right, so there you are. Not this one. ImGray, okay. ImGray.jpg. You edited just now. So ImGray. So this is under my drive. Okay, I think somewhere inside here. Looks the code. Content Google Drive, Colab Notebooks. Okay, under Colab Notebooks folder. Colab, okay, under this folder. Okay, there ImGray. Okay. What time did you? 9/11 today. So today is 9/11. Okay, good. Now, right. But actually, it automatically is saved there. But it's just to show you how to mount a Google Drive. And this is what EG1. Okay. Oh no, nothing. It's the same thing. You just rename it to EG1. Okay. And, this is what resize. So you can resize your image from the Google Colab, from the drive. So take the image from the drive, resizing it 28 by 28. So you plot this one. Image size is a grayscale. So this become 28 by 28. And this is the print image. 28 by 28 mean 28 times 28. How many pixels are there? So these are the pixels from the first row. Okay. Okay. It show in metric, array.
Yep.
So yeah. Okay. Now this is what resize 2 by 2. The same IM1. I think it's above. Okay, there's only 2 color there. And if you print this, hold on. So I just want to know. Just hold on. I think grayscale is 1 bit. Okay, grayscale is 1 bit. No 3 channel. So this is not a 3 channel. This is 1 bit. Okay, this is 1 bit. So now just okay, I just want to make sure we cannot just assume. I think it is 1 bit grayscale. Okay, 28 by 28. So here we're gonna IM1, isn't it? 1. Okay, IM1. Okay, so let's look. Okay, 2 by 2. So no number 3. If we got 3 here, mean 3 channel, mean it is grayscale. Or color 8 bit. So you got a size of 4. 2 by 2 is 4. 4 pixel. Okay, and the value of 4. This is the first. 108 is here. 146 is here. 61 is here, and 70 is here. So this is you're working on 2 by 2. Normally you are working with 712 by 1000 something. So a big number. In here you got 2 by 2 small number only 4 number. Now just so this one will be bit straightforward. Okay, I'm going to use Panda basically just to show you something on Panda. Panda is another library, data frame. NumPy is you convert the data into array. Okay, Panda you see data is a data frame, right? So this is the same image M1 above there. Remember? So these are the same image here. Remember? I just resize it, and the shape is 2 by 2. Remember? And now I want to use Panda to change to data frame. Okay, so data frame is good for you for that for data analytic, because you got age, salary, all those things. This is row, and this is column. So this is customer number 1. This is customer number 2. The age, the salary. Remember data sign? Normally you're working on that data.
Yep.
Yeah, this is images. So images is not age and not salary. It's the pixel. Okay, got it?
It is the location of the pixel in the
Yeah, good. Okay,
in
let's
the
see.
image.
Yeah, let's see. I think this is a good question. Let's examine it. And 104. because you have changed your data frame. I think you remember this one, okay?
Yep.
IM1 because we changed to data frame now. And okay. So I think this 0 and 1 is about column and this is about the pixel. I think it is column 0, row 0, the pixel is 108. So means that column 0, the first column contain row contain 108, the second row contain 146. Okay, I think still like that because nothing more than pixel value. There you see there. If we let's print this one there and let's see what happened. Mana tadi ini, okay? And code, okay, just IM1, okay. All right, see. So it's just change like that. Okay, got it? Okay. Who's asking me just now? Mr. Learning. Are you learning?
Coming.
Huh? Coming, okay. So this is coming, okay. I think you're computer science, isn't it?
Yep.
Yes. Okay, now the data science student, are you okay? Data science. Well, you can refer my recorded lecture. I think it's pretty straightforward, okay? And you can refer to Coming as well, asking on this, okay?
Yeah, Doctor, I see that the method that you use in this tutorial, right? The grayscale image were used because of the Panda data frame does not support those images that have like 3D data, right?
Yeah. Yep, that's right. Anyway, you can try later on 3 channel or those channels. But we don't use data frame basically in images, you know. But I don't know. Let's see later on because we're gonna see row and column as the image, okay? Because data science you have row and column as well. The column will be employee name, employee number 1, employee number 2, and then the column will be salary, age, all those things. You know, you got 10,000 of customer pattern of paying the installment monthly installment on car for 5 years, and you got 10,000 customer. So you know the habit or which one will be approve the loan later on, which one will not be approved the loan. So in that case, you're going to have that for, and this one for the data sign. I think we don't need row and column. Each column we're going to be one image. Coming, are you okay?
Yep, I'm okay. Yep.
If you data sign, each row will be one customer. If you got 10,000 row, mean you got 10,000 customer. And the column you're going to have a pattern of their age, monthly payment, salary, address, and all those things, and behavior, all those things. So on the left side, I think the row you're gonna have 10,000 mean 10,000 customer. In images, if you got 10,000 row, it means 10,000 images. We are not working with pixel. So the content one image is all the pixel, 28 by 28, 712 by 1024. Never mind. If you don't follow this one, we'll see later at the end when we go to deep learning, you're going to see this. Because this one, we go to deep on pixel value and small 2 by 2, 1 by 1, just simply to show you some example. If we use big resolution, 100 by 100, it's going to be like this number. So it is this number basically. It is 28 by 28. Okay, this is 28 by 28. You got like this number. So this is not the good example to show you. And 2 by 2 is the good example to show you like this. Okay, so this, you can do the rest. Okay, this is the shaping shaping mn to metric 1 to mn. Okay, change the value now like this. It become It's 2 by 2 metric, now become 1 by 4 metric. Okay, and you're gonna have this one, I don't know, okay. -1 mean this one, print Y. If you print Y, the same topic here. You are reshaping from M. This is 2 by 2, 2 by 2 into 2 by 4. This is 2 by 2. You're going to change this 1 by 4.
Yep.
So 108, 146, 161, you move there. So you can play around. That's data frame or NumPy array is the same, okay? But data frame is more easily understand lah when you do this. So this is what, and you can, then from there you can, so you got Y here. So Y you can have a data frame and you got like this. Okay. All right. And I think about the data frame, NumPy array, you can start working on your own. Okay. So this is what, this is flatten. We need to flatten later on in deep learning. Okay. We flatten the Y. This is why we flatten, and then let's print. So this is mean flatten, okay? You put in one row. Okay, just one row. So this one row will be inputted to data to the neural network. Easy for that, okay? Later on we'll learn on this. So this is to reshape. Deep learning also did a lot with reshaping the image. Reshaping into 2 by 3, 4 by 4, and then change the channel from 1 to 3, 3 to 4 to 6, and so on. Okay, and this is what W here is changed to data frame. Now it's a bit different. All right, then I think we stop here.